what we're going to do is create an Excel spreadsheet to make your life easier, way easier, by letting Excel do all the math for you. So what I would do is I would pause this right now. You don't need this stuff over here. I'm just showing you what I'm doing. But I would pause this video right now, and I would type all this information that you see. Okay, so pause it, and I would even double click down here and name this testing two proportions. All right, so hopefully you paused it, you got everything here, and we're back. So I know that this is a proportion because it shows like so many out of so many, okay? And so I at least know that this is a proportion test. It's going to be a right tail because it says greater than. We think one proportion is greater than the other. And so, and I explained the problem in the live session, but here I just want to get the math. So my p hat equals my x divided by my n. Do not forget to always start with an equal sign. My q hat is 1 minus my p hat. Okay, so that's my q hat. And then check this out. If I click and drag and highlight those two, and then I notice the cursor changes from the fat white cross to a skinny black cross, I click and drag it straight across. What that does is copy the formulas. I mean, you could have typed them in, but it's kind of nice because it makes it quick to do the formulas. Okay, so that's that. And I should mention up here, you can change the decimal places if you want more, you want to see more, you want to see less, and all that good stuff. So I know to find my test statistic, I need this formula. This formula, if you look in the denominator, there's this thing with a P with a line over it called P pooled. And I just add the two X values and the two sample sizes. So I can do that, equals. I want to force it to add the numerator first, so I put a parentheses, X from sample 1 plus X from sample 2, close the parentheses, divided by, I want to do the sample size 1 plus the sample size 2. Notice my use in parentheses. I think from what I'm seeing with your guys' papers is it's just how do you put it in your calculators, right? So even if you're hand doing this, which I would not, I would set the spreadsheet up, you have to force it with those parentheses. All right, so here Q pooled is just equal to 1 minus P pooled. All right, so I have everything I need for this formula. Now you could just do this in one step. I just think the formula is kind of long. So what I do is break down the numerator, the top up here, and then the denominator, and then I'll divide them for my actual Z test statistic. So the numerator is pretty easy. It's just saying the difference between sample 1 and sample 2 proportion. Remember this piece right here is saying there is no difference, so that would be 0. So I mean, you could type minus 0 if you want, but it doesn't matter. All right, and now here my denominator a little bit more drawn out, so equals, I see a square root. I open the parentheses for everything to be in the square root. Now I open a parentheses for the numerator. This says P pooled times Q pooled. I close the parentheses, divide by N1, which is the sample size, plus, now I do once again a parentheses for this numerator, P pooled times Q pooled, divided, close the parentheses for the numerator, divided by this sample size, and close my square root. All right, when I hit enter, hopefully I get a good number. And now from here, I'm just finding my Z test statistic equals this, the numerator, divided by the denominator. So this is the actual value, my value that I'm interested in. This was just how to get there. Now, you know, if you go look at your table and look up 6.44, our table doesn't go that far. So basically, we're saying that this is a really, really small chance that we would expect to get that value. So we're going to expect our p-value to be very, very small. If you could look this value up in the table, and we are doing a right tail test. How do I know that? Because it said greater than. Remember, to get the value to the right, you do 1 minus the value in the table. I'm going to use Excel's formula, so equals 1 minus my norm.dist. I click on my z-test statistic, and then I type true, and I close my parentheses. So this is a right tail. However, we want to make a spreadsheet, and I'll hit enter. We want to make a spreadsheet that will do a two tail and a left tail, because every question on the quiz and the homework's not going to be a right tail. And as I mentioned, you can see that this probability is, wow, really, really small, right? And so in this case, the two tail's kind of easier. It just equals this value times 2. Okay, still real small. A left tail would just be the value you actually look up in the table, so I don't put the 1 minus part. But what this has done is this has allowed me, for this problem, that's the p-value for this problem. But if I had a alternative hypothesis that was not equal, or if I had a alternative hypothesis that was less than, then I have my p-values here. All right, so now I'm going to set up my critical value, 0.01. This would be a cell that you would change. That's just for this problem. That's why I put the highlighting, to know that this would be a cell that I would actually click in to change. Then how do I look up my critical values? Well, I can either looking them up in a table, my Z table, or I can set up a formula so I never have to do this again. In this case, looking up the 0.01, remember you're actually looking up 0.99, 1 minus that value. All right, so I get 2.33. I certainly would like to have this if it's a two-tail test. So if it's a two-tail test, what I'm going to do is equal this value, okay, and divide by 2. So that way I wouldn't change this cell either. And so then I do the same exact thing. And in fact, I could just copy, well, no, never mind. I was going to say I could copy the formula, but I don't want to copy the formula because I don't want to do 1 minus. Now, here is something that, so I'm going to start with my equal sign. When you have a two-tail test, you have a plus and a minus critical value, right? In the tails, you have to the left will be negative, to the right will be positive. So let's type this in here, norm.s.inv, and then I click on this value, my probability, and I get negative 2.58, which is fine, but I need to know there's 2 critical values. So what I do is I just do the absolute value of that number, and all that does is make it positive. So equals ABS for absolute value, and this shows if I have a two-tail test that those are my critical values. All right, the critical value is the same whether you're doing a left or a right. The only difference would be if you're doing a left, it would equal the negative of that value. And I mean, this is important you understand why, right? Because if you're to the left of the mean, those values are negative. Okay, so that's pretty much everything that I need to work this problem. However, you're going to have some problems that are going to ask you to do a confidence interval. And for instance, your quiz, I scared you when I said test, huh? So for example, your test, might ask you to do a confidence interval. Remember that when you do confidence intervals, see the Z alpha over 2? So this one wouldn't make sense to do a confidence interval because it's not a two-tail. But if you were asked, make this a confidence interval, then I would use this formula for my error. So I'm going to find error first, which equals my positive Z value for the two-tail, so the 2.58, times, now I got to do all this junk here, so the square root, open the square root, open the numerator. I'm following this right here. It's my p hat from sample 1 times my q hat from sample 1 divided by my sample size plus my second fraction numerator, p hat from sample 2 times q hat from sample 2. Close my numerator, divide by my sample size, and close my square root. Okay, so that would be all of those values. So that's my error. So how do we find the lower confidence interval? We take p hat of the sample 1 minus the p hat of sample 2 and subtract the error. So I take p hat sample 1 minus p hat sample 2 minus my error. And then I do the upper, which is the add. So p hat minus p hat 2 plus my error. Okay, so that would be my upper and lower confidence interval. In fact, I might move these. So what I'm going to do is I'm going to actually cut them and just move them closer. I'm just going to hit Control V. Okay, so they're just right next to these. So this would be if you were asked to do a confidence interval. So basically what I have created, and you have, if you went through all these steps and you got all these answers, then you can work any proportion, and all the only things you have to change are these values. I mean, that's the only thing you have to change. If you're given percentages for your p hat and q hat, then you could type them in here. You just have to remember to put your formulas back. Okay, so what if they just give me 22% of these people? Well, then I could type 0.22 in here, but then I'd have to remember, I just remember to undo and then put my formula back. And that's it. If you will set these up, you'll see the hardest part is then deciphering your answer, which is what we're going to do in the live session.